a Portland Community College mathematics telecourse. A course in arithmetic review, produced at Portland Community College. As with fractions, many people have a hesitancy about ordering decimals, deciding which one is larger and which is smaller. You would be surprised at how many people will think that this is the larger because it begins with a 9 and this only with a 1. But as it turns out, this is the larger one. Now, after all, decimals are fractions. Let's write these. This is 125 thousandths. But this one is 936. And see, the average person says, see, that's larger than that. But this is 936 ten-thousandths. And recall from fractions days, we could not order fractions unless they had the same denominator. And I can make this 1,000 become 10,000 by multiplying top and bottom by 10. But if I do that, this top has become 1,250 ten-thousandths, and this one, of course, still is 936 ten-thousandths. So in this form of having common denominators, it's quite obvious that this is the larger number. So the secret was in the form of having common denominators, we only look at the top. Well, in decimals, to say common denominators is the same thing as saying let's have the same number of places. So this one has 4 places, this one only 3. But you remember a tape or so ago we said that with a decimal, on the end you can append or take off zeros to your convenience. In this case, it's one of our conveniences to append a 0. Now, if the two have the same number of decimal places, it's the same thing fraction-wise as having common denominators. Now we can look at the two, and we can see that 1250 is larger than 936, so that is the larger. So the secret for ordering decimals is to be sure that they all have the same number of places, appending zeros if necessary to accomplish this. Then pretend as though the decimal isn't there and order them by the way you see it. And 1,250 is larger than 936. Now it becomes even more obvious when we have a series of decimals if we align them vertically and keep the decimal points in a line. So 1.2, this one would be 0.056, this one would be 0.135, and the last one 0.0092. So keep the decimal points in a line and the like places, tenths in a line, hundredths in a line, thousandths in a line, and 10,000ths. Now, if it will help you to visualize things better, on the end, append zeros either on paper or mentally until they all have the same number of places. And now pretend like the decimal points aren't there and ask yourself, which is the smallest here? Well, you can see quickly it's this one down here. So this is the smallest. Then the next smallest would be the 560 here. Then the next smallest, 1350. And then, of course, that makes this the largest. With very little practice, you can do this mentally without going through this trickery. but this is useful until you're comfortable in beginning to think in terms of size. Let's do another one while reviewing our symbols. Recall what this symbol means. You'll see it more and more in your later math. This means greater than that. So the question is this decimal greater than that decimal? Well, this decimal has 1, 2, 3, 4 places, so this one has 1, 2, 3, so we append another 0. Now if we look at them without the decimal points, this side seems to have 1,250, whereas this side has only 375. So indeed this one is bigger than this one, so the answer to this question is yes, that is true. Now let's recall that this symbol means less than. So we're asking, is 0.48 less than 0.051? And again, an inexperienced person would see this as 48 and this is 51 and say, of course it's true. But they're not taking into account the decimal system. And to compare decimal numbers, they must have the same number of places. So there's 2, there's 3, so I append a third place 0. Now ask the question, this is 480, this one is only 51, so this is much bigger than that. So the answer to our question is no, that's not a true statement. 3 service stations advertise unleaded gasoline. The prices are as listed here. Which is the most economical? That is, which is least? And our technique simply suggests to us to write each price with the decimal points lined up. Keeping the place values in a line, tenth, hundredths, thousands, 10,000s. Then, if it will assist you, append zeros on the end behind the decimal point, which you can't do with whole numbers. Then, at that point, simply pretend like the decimal point isn't there and ask yourself which of these numbers is the least. And one can see, since whole numbers are easier to judge, that this one would be the least, and that is A. So A has the best price. Now, of course, if you can just see because your sensitivity to numbers, that's well and good. But this is a device which helps you bridge the lack of that sensitivity until experience gives it to you. Let's do another problem like that, but at the same time developing some ideas and some language skills that will help us go from this lesson into addition and subtraction of decimals, which will follow this lesson. First, in order to find the order, if we don't have a sensitivity to sizeness just by looking at them, see, an experienced person would look at this and say, this is the smallest, this is next smallest, third smallest, and this is the largest. But if you didn't have that sensitivity, at first we said this, and I'm going to correct it in just a moment. We said to write each one lining up the decimal places, the decimal point. So 1.005, and this is lining up the decimal point, 2, 3, and of course the 0 in front isn't necessary. And the next one is point, lining up the decimal points, 507, and the next one is 0.053. Now what we really need to correct is the idea that it's really not the decimal point that we're lining up, it's the place values. In fact, we want all of the digits in the tenths place lined up. We want all the digits in the hundredths place lined up. We want all the digits in the thousands place, and so on. Same thing with the whole numbers. We want the digits in the ones place, then tens, and then hundreds if we had them. So it's really not the decimal points that we're lining up, it's the places. The decimal points are merely there to help me find where the places get started from. The reason I say that is that there is a tendency to make a careless mistake by some people. Instead of writing 0.23 like this, to write it perhaps like that and just leave a vacant spot here. But I can't have the hundredths place in the thousands place here. All the hundredths place must be together in the same position. It's very important that you follow what I'm saying. Then append zeros if it will help your thinking. Then also, if it will help your thinking, pretend like the decimal points aren't there. So if the decimal points weren't there, then of course this 0 is not necessary, nor is this, nor is this, or this. So therefore we could see, just knocking off temporarily, those temporarily unnecessary decimal points, that this is the smallest. Well, actually I couldn't really knock this off, so this is really the number 0.053. It's the smaller, so it will be less than the next one. And we can see now 230 is certainly smaller than 507, so this is my next smaller one. And of course I don't need that 0 anymore, so there's no point in writing it. That will be smaller than my next one. And we can see that 507 is certainly smaller than 1005. So this will be less than 0.507. And we have one more left over, which is 1.005. So we have these rearranged from the smaller to the larger correctly. And we said to get our thinking onto paper to line up the decimal points. But we want to now realize that in fact we're lining up the tenths, the hundredths, and the thousands, and so on. So in actuality it's the decimal places of like values that must be lined up. Keep that strongly at the back of your mind. In fact, let's carry that notion right back to our whole number addition which we had at the beginning of this course. Remember, if we were adding a long string of numbers, many of us learned the rules that we must write these vertically, and as it was stated then, we must line up the right ends. And now I hope you're beginning to realize it's not just the right ends we want lined up. We want all the units in a line and all the tens in a line and all the hundreds and all the thousands. So in fact it was not the ends we wanted lined up. That's just to help us get started writing. It's the place values we want lined up. Therefore, if one were careless, as some beginners tend to be with a situation like this, you might tend to write something like this. Sort of spread your digits around and you suddenly realize that's illegal. I cannot add tenths to hundreds, and I cannot add hundreds to thousands. I can only add digits from like places. And what we're saying now is it's the same with decimals. That's why in chapter 1 we made such a big deal, and we are now again on place values, because all of our instructions that we give you are in terms, in fact, of place values. Let's actually take a moment out and take a peek into a future lesson, and you'll see why this is so important. When we're adding decimals, rather than saying, as we did with whole numbers, to line up the ends, we will start our conversation by saying, line up the decimal points vertically. So this would be 1.03. This would be 0. But now we want to realize it's not just the decimal points we want lined up. We want the tenths lined up. We want the hundredths lined up. And we want the thousands in the next column. Of course, there wasn't any thousands here, just hundredths. But if I wanted to help my visualization, I could insert this extra 0 that we've talked about. And now we have 30 thousandths, which is the same thing as 3 hundredths. Same thing here. Beginning our thinking by lining up the decimal points, but carrying it through to line up the tenths, hundredths, thousandths, and now 10 thousandths. And if you need or desire this appended 0, that's fine. Just give it to yourself. Now we add, and you're going to see here the extreme advantage over decimal fractions to pure fractions. Because once we have lined it up all the like place values, then the rule you're going to have in another lesson or so is simply pretend like the decimal point isn't there. Of course, we're really keeping them all in a line, including the decimal point of the answer. But we keep it there, and then we just add as though this was not a fraction problem, but really a whole number problem. So we're just adding as though we had a whole number problem. But in fact, we have done a fraction problem. There is the great beauty of the invention of the decimal system. It allows us to work fractions, which are quite messy, as though they were whole numbers, which is quite easy. But here again, note, we started our thinking by saying line up the decimal points, which, by the way, we will do for addition and subtraction, but not multiplication and division. They have a different rule. But then following through by actually lining up the like place values, then temporarily forgetting the fact that I have a decimal point and adding as though I had a whole number. And I'm done working the fractions. Isn't that neat? Now note the similarity between what we just did by peeking ahead and this current lesson. In order to order decimal numbers, we're going to visually line up, starting with the decimal points, lining up the like place values. So this is a 2 and 5/10. But here again, be careful. This whole number does have a decimal point. It's just that it's understood to be behind it, and we don't write it there unless we need to. Well, now we need to, because we want to line up the like places. So the units with units, the tens in a separate column. Now here again, lining up the point, 0, 9, 2. Now that's a units digit, tenths digit, hundredths digit. Now with some experience, you won't bother writing these zeros down. You'll simply go down here, add the next column, if you're to add. But if you're to order, as we are here, as a beginner, you probably still will find it more convenient to append the zeros. Now, for a brief moment, we pretend like the decimal points aren't there. And of course, in this case, the decimal points weren't there. We wouldn't have to worry about that 0 either. Now, it's real easy to find the smallest. In this case, it would be this one, which in its original form, which we have to go back to in the final analysis, is the smallest, which means it will be less than the next smallest, which we can see now is going to be this one, which in its original form was 2.5, which would be smaller than the next. which we can now see is 7 is certainly smaller than 15, so in its original form is 7.05, which will be less than now the last one, which is simply 15. And again, make a mental note that all whole numbers indeed are also decimals, and the decimal is always here, never anywhere else, always here on the right end. That's again a common mistake for many beginners. It's always on the right end. And we have ordered our fraction. So note, there's a pattern here similar to what we just did for adding, and as you'll find later, similar to subtraction. So be very, very cautious of the subtle similarities as well as the differences so that you won't get confused in the future. To show you the importance of this, here is a problem like situations which occur very, very frequently in all of science and technology, particularly chemistry. Let's say that you have a vial which is supposed to contain this many grams of a particular substance, in this case charcoal. Let's say a person, Jerry here, wishes to double check this, so he weighs it on an extremely sensitive scale, and reading as well as he can, he determines that he has 4.21 grams, which is not the same as this. Now, if this is correct, is Jerry weighing too light or too heavy? And so if we want to compare this, we're asking really, is this smaller than this or is this greater than this? And what I'm doing on paper, ultimately we just do mentally, lining up the decimal points, that is the decimal place. We can see they're the same here, they're the same here. Then this is the first one that's bigger than this one, so this is the larger number, so Jerry is weighing too heavily. We will look at this situation very, very frequently and very closely in the next lesson, because it might be that Jerry's scale is incapable of reading past the nearest hundredth of a gram, because that's minutely sensitive. So he'd need better scales to get down to here. So if his scales could only read to the nearest hundredth, and this is what it really was, we will ask in the next lesson, is this a reasonable measure of this when I have less accuracy? So our next lesson, in fact, is going to be approximation and round-off accuracy. Because, in fact, when you're measuring things in reality, you can never measure them exactly. That's physically impossible. So you can only measure things to certain amounts of accuracy depending upon the kind of instrument you're using at that particular moment. So bear that at the back of your mind. That will become an important point in not only a future lesson in this course, but in all of science. Here's another. Margot and Josh each measured the diameter of a coin and got 0.81 and 0.807 centimeter respectively. Which measurement is the smaller? Now again, a beginner might see that 8.7 is larger than 8.1 and say, hey, this is smaller and this is larger. But here again, let's line up the decimal places. So 0.81 is Margot's measure, and Josh's is 0.80, lining the hundreds with the hundreds, 7. And now if we wish to insert that extra 0, that's fine. And we can see that in fact is Josh's that is smaller, not larger. Again, for those of you who are taking this program that might eventually take a science class, this is a very frequent classroom experiment at the beginning of a course. It's for the instructor to give everyone a very accurate measurement scale, centimeters, calipers, whatever, and send the same object all the way around the room and ask everyone to measure it as carefully as they can and write it down. Now, the same object, the same kind of measurement scales, and yet you'll find that it is the rule rather than the exception that most people will not measure precisely the same. And your science class will discuss why that is so. But again, you'll find that they will be close. And it's important for us to determine later how close, and in this lesson, of the different measures, which is the smallest and which is the largest. And also be aware that sometimes you're trying to order things not from the smallest to the largest, but from the largest down to the smallest. So again, you line up, beginning with the decimal places, but actually lining up the places, not the point. So 1 unit rather, and 2 tenths. No units, no tenths, 3 hundredths, 4 thousandths. And then no units, 2 tenths, no hundredths, no thousandths, 5 ten-thousandths. And if it will help you, to insert enough zeros so that you can visually compare these easier. And this is what we meant in the last tape by these zeros being for looks only, cosmetics, if you will. It just helps you to orient your thinking. In value, in fact, they serve no purpose whatsoever. But now, pretending as though the decimal points aren't there, we can see that this, in fact, is the largest, and it came from 1.2. Then with that out of the way, our next largest we can see is this one, which is 0.98. With it out of the way, we can see this is my next largest, 0.2005. Then finally, that leaves us with the smallest, which is 0.034. And notice in all of these cases, I did not write the 0 in front of the decimal point. But again, I can, or I don't have to. The value remains the same. So you will find, I trust, this is an extremely simple lesson, but you will also find it's a remarkably important one for the future. Until your next lesson, this is your host, Bob Fennell. Good luck.